I recently learned about the crew package in R. Crew is written by Will Landau, based off of Mirai, another R package, which is itself a parallelization technology. And Crew is came onto my radar as a potential place to tool to use for running simulation studies. Um, and so I'm going to use it today to just run through the example in the seminal paper by Tim Morris, Ian White, and Michael Crowther, called "Using Simulation Studies to Evaluate Statistical Methods." They give in their paper an example, and I'm going to use Crew to replicate that example with some R code. So just going to run through these, loading up some fairly common packages that we're going to rely on. Don't worry about trying to keep track of the code necessarily, because I'll stick it in a gist on GitHub. But this is the first thing we have to do, is to create a controller using Crew. And I'm using a local controller because I'm running on my laptop, which has 8 cores. So I'm going to use 7 worker cores, and I'm going to leave 1 core for the GUI. And then we just define some functions. So this is the data generating model as specified in the Morris et al. Paper. This function here is just a little helper to provide a tidy summary method for this particular type of model, which isn't actually covered by Broom. So I'm just implementing a generic. And this function here, Morris et al., just runs one simulated iterate. Just to run through the steps, you can see that it samples some data using that function we just defined. It then fits each of 3 models: a Cox model, an exponential model, and a Weibull model. These are the 3 models that Morris et al. Investigate. And then as an output, I choose to sort of tidy those as data frames and just provide some descriptive information. Right, so I'm going to use the map function of the controller object. And what that's going to do is that it's going to map to those 7 workers this command, run Morris et al. For I in this list here. So this is a sequence of length, well, n underscore iteration was set at the top to be 1600. That's the number of iterates that Tim and co-authors chose to use in their simulation study. So for I equals 1 to 1600, you get a call of this function here. I have to specify the packages that I rely on for each of the workers, and also in globals I have to provide a list of the function names that I've already defined, so those get pushed over to those worker threads. So I'm going to run one batch with the gamma parameter set to 1 for scenario A, and then I'm going to run scenario B where the gamma parameter is set to 1.5, and this mirrors what the authors do in their paper. And I'm also going to time this whole thing so we can check out the speed. So I'm running this on an M2 MacBook Air, and you can see over here it's blitzing through the tasks pretty quickly. So this first batch for scenario A is running in, let's see, took about 24 seconds, and it's now running scenario B. I wonder if I can switch to no, I can't switch away when I'm recording an app. Okay, that's fine. So scenario B is just running 2. And that's taken about 24 seconds too. So I'm going to bind those results together into one great big data frame and then produce a plot. And here we go. This plot here more or less mirrors what Tim Morris and co-authors report in their paper in their figure. Just looking up the number, figure Figure 3, the left-hand side of their figure 3 in their paper basically has a plot similar to this, and what it shows is that the exponential model in scenario B, where that gamma parameter is not equal to 1, that exponential model struggles, as we might expect. So this command here just kills off the controller, and what I provided at the bottom of this script is the ability to rerun the whole thing serially. I'm not going to rerun it, but I've done it, and obviously parallelizing over 7 cores is much faster than running it serially, and getting that running on the crew package was, I've got to say, really simple, and I'm going to investigate next whether it scales up to a high performance computer with lots of cores.